Okay, we start with chapter 2. There'll be more and more information coming in. We roughly will spend about 45 minutes or 40 minutes for this session. We won't, I think we cannot cover all, but we try to go as much as we can. So later we will learn about what happened to inside the atoms. We'll look into atomic level now. So we later, once we clear the structures in atomic dimension, then we go into bonding, start to look into a bigger dimension, atomic, electron dimension. Then we go get bigger. Okay. So the word atoms actually was discovered about 460 BC by somebody, right? It's a Greek metallist, right? So the word the time, and that time, I'm not sure whether that time have a microscope or not. But this guy, he had discovered the properties of material in mathematics and so on, right? Okay. Recall what you learned in chemistry. In particles, you can zoom in, then you will see electron, proton, and neutron, right? You don't need to memorize all these numbers. What is important is electron will give you negative charge, proton will be positive charge, neutron don't have any charge. Right. Now, first important diagram is called atomic diagram. This is nucleus. Nucleus. If you zoom in nucleus, you will see proton and neutron. Then this region is where the electron is running around. Okay. So this is under photograph under microscope, under quantum microscope. You will see heat signature and all this, right? Electron wave. So let's watch this video. We already come to area we can control an atoms at the atomic level. This video created by IBM. Okay. So when you look into atoms, we need to draw how atoms move around, right? How electrons move around. So this discipline is called quantum mechanics. And the one that you see on the screen here is called Bohr's model. It's called Bohr's model. How you draw Bohr's models? You draw center as nucleus. Then you draw orbit with electron. So this is called Bohr's models. So we will start to learn how to draw Bohr's models for the first session. Nothing complex. We just show where is the nucleus, where is the electron, where is the orbit. If the electron is inside the orbit, we call it orbital electron. Then inside there is nucleus. The rest you read. It's important that, okay, in our class, you know what is atomic Bohr's models, atomic Bohr's model. In test 1, you'll be asked to draw Bohr's models for certain elements, extract information from periodic table. Now we start to look into elements. So if you see this element carbon here, so carbon is given by number of protons with its atomic number, which is the Z, and atomic mass is below there. Okay, so the one on the top is called atomic number, which is number of proton inside the nucleus. So again, inside nucleus here, you have proton and neutron. So the one that you see on the periodic table is a proton, with its number Z. Then the one below the chart here, or in the periodic table, you see a number there. This is atomic mass unit, AMU, which is 1 mole of this element have this weight in gram. Okay, for example, carbon, 1 mole of carbon have 12.011 gram. Okay, so why 1 AMU is 1/12 mass of carbon means the whole periodic table, the number below here, they use carbon as a reference. They compare using carbon. Okay. So once you have the Z value, let's say carbon, you have 6, right? Let's say carbon, you have 6. It means inside nucleus there, you have 6 proton. The atom must be stable. Means this proton is positive charge. You need another 6 to stabilize the atoms. So how you stabilize? You need to know, once you have the Z value, you know that minimum electron that outside the orbit is how many? So for example, carbon, you have 6. This one is a neutron. It will be the same. This one will be the same. Neutron also 6. This one is electron to get stable one. Okay. Mass number A is proton and neutron. Okay. So this is from element. Then this one, sometimes I give you a symbol, something like this. So if you see 2 number, don't confuse with the location. Periodic table one is proton. If you see chemical presentation with 2 number, on the top is mass number, below one is atomic number. There's no AMU unit here. So don't confuse with this one and this one. Okay, so these are the careless mistakes when it comes to test 1. Students or some of you might confuse this value. Okay, the one that you see in the periodic table is proton. It's proton. So If the question gives you two numbers, the one at the top is mass number, which is the total number of proton plus neutron, which is what happened inside here at the center. Then atomic number is how many protons it have. Okay. So by having this illustration, you know how many neutron you have. So it's a 6 neutron, for example. Okay. I think this one you're familiar already. Okay. So sometimes this carbon 12, we'll just write 12 carbon, something like this. 12C to represent carbon 12. Okay. Okay. Another one is called isotopes. Isotopes means they have the same proton number. They have the same proton number. They have the same Z number. Isotopes. Example of isotopes. So this one, what do you think? How many neutron hydrogen have? How many neutron? What is this number? Proton, right? This number is proton. Proton is Z. Neutron will be the same, is 1. So these are the isotope of hydrogen, protium, deuterium, tritium. So if you write in a two numbers presentation, protium is 1, 1. Deuterium is 2, 1. And tritium is 3, 1. Again, don't confuse between this presentation and this presentation. If you see only one number, this one is proton. If you see two number, on the top is mass number, below is atomic number. Don't confuse with the presentation. Okay, so when you see this presentation and below there, when the atomic number is the same, they are grouped under isotope. Means the element must be the same. The H, and the number at the lower left corner is the same, then they are isotope. They call isotope. Okay. So try to remember what are the example of isotope. Now the first one is hydrogen. So remember these three names: protium, deuterium, tritium. Another one is called atomic mass unit. So we want to know, this number helps us to know how many atoms inside 1 gram. So 1 mole of something will give you 6.02 10 power 23, or equal Avogadro number, or Na. Na number will be 6.02 10 power 23. This is called, it can be atoms or molecule. The unit can be atoms or molecule. So this number, we assume you already know this number won't be given in all the tests. You won't see this one in test 1, test 2, or final exam. We assume you know, like you remember gravitational force, G equal to 9.81. Right? So this is the first value you need to remember for today. Okay. Avogadro number. This one represent 1 mole. 1 mole of something will equal to 6.02 10 power 23 atoms or molecule. So for example, carbon, 12.1011 gram will have this many atoms of carbon. So the first calculation, very simple calculation. if you look at carbon 12, what is the mass of a carbon 12 atoms? Do you know how to calculate? If the question asks you, what is the weight or not? I cannot use weight now. What is the mass of one single carbon 12 atoms? Do you know how to calculate? So 1 mole of carbon 12 will have 6.02 then 23 atoms. So 1 mole of carbon will give you 12.011 gram. So you do the calculation. Okay, 6.02 10 23 atom will equal to 12.011 gram. So 1 atom equal 12.011 divided by 6.02 10 power 23 gram. Okay, so I assume you already have a very good mathematics already. You have to know how to do indexes, all these things, and familiar with the calculator that you use. So you press the calculator, you get something 10 power 23 minus 23 gram, something like that. About 2 point something. 2 point something or 1.9 something. Okay, so this is how you do. So this is a very basic information that we can extract from periodic table to calculate something. Right? So first number, Avogadro number 6.02 10 power 23 in 1 mole. Okay, this one we already mentioned. So I did calculate for you. 1 atoms have 12 AMU or 12 gram mole. In simplified, actually it's 12.011 AMU and so on. This mass is a relative atomic mass or molar mass or atomic weight. It's an average. It's an average. When you see the word relative, these numbers will change when it comes to polymer. Okay. So far, any question? Able to do? Okay. Now let's do some exercise. Let's do some exercise. So this exercise actually tell you that if you're given different ferrum, as you can see here, these are isotopes of ferrums. So this is ferrum 56, 54, 57, 58. Again, this is one number presentation. So if you see isotopes presentation, the Z and the, sorry, not Z, the number here and number here, this one is the same, then will be isotope. But this one is only single number. So we look at the Z number. So if you're given a ferrum, 4 type of ferrum, 91%, 5%, 2%, 0.2%, you have a different AMU or atomic number. Right? Ferrum 56, you have 55 something. 54 ferrums, you have 53 something. This is in gram, gram per mole. So what is the average weight of a ferrum? Okay. This one you add all this percentage together, you get 100%. So to find the average atomic mass, how you find? It's just a simple mathematics. You take all these things, divide by 10, or you take this one, become divide by 100. This one you get 0.91. Multiply by this number. This one divide by 100. You get 0.05. Multiply by this number. You take this one, divide by 100, 0.02, multiply by this number, plus this one, divide 100, multiply this number. You will get the average. This is a distribution of materials. In your SPM secondary school standard education, you assume all these are the same. You are being taught that forum only have one type. Or maybe in your chemistry class, you will see 3 types of forums. Red color, orange color, green color in your chemistry class, right? So you press your calculator, you'll get 55.8 something. It's an AMU. This is 1 ferrum atoms in AMU unit. You will see 55.8, this number, in the periodic table. In periodic table, you will see the numbers, let's say ferrum something. You will see this number 55.8 under there in the periodic table. Okay. Now, what is the relative atomic mass of atoms? It's the same. Average is how you calculate. Relative will be the same. But the unit become with gram. Basically, they are same meaning. It just when you use AMU, the unit is AMU. If you use AMU in material engineering dimension, you are actually mentioning average atomic mass. If your answer you put gram, you are using relative atomic mass. All right. Same but different. It's a unit different. Atomic what? Relative atomic.
The atomic mass. It means always atomic mass means the mass of the atom itself.
Yes, atom itself. Sorry. Mean this one is in 1 mole. With 1 mole, you have 55 point something. Right. So this number is always 1 mole. Always in 1 mole things. Okay. So periodic table, this will be the one that you see in your test 1, test 2, and final exam. This one you see in the appendix at the last page of the final exam question. All right. So make a good friend with this one. All the information is there. Basically, if you understand this one, you don't need to memorize a lot of things. So in this table, can you find ferrum? You find Fe. Maybe a bit smaller. Where does it? Column where? Row where? Can you find Fe? Can you find it? Can you find it? Which row? Can you find it? Yes or no? Where is Fe? Huh? Row 8, column, row 4. This is row. This is row. So there's number 1, 2, 3, 4 here. 4, row number 4, column 8. So you see the number below there? 55.85. So this number, usually we'll just use gram in our analysis. But sometimes the question can ask you AMU. When the question is AMU, it means that he asks you to find the missing distribution here. Understand or not? You understand? Okay. If your question is in gram, then that's it lah. Gram usually is to find mole, 1 mole how many. But if the question give you 55.8 AMU, the question actually reverse back, ask you what happened inside here. So actually the question reverse the things. If you see AMU means you're actually looking at isotope question. All these isotope it's the same proton but this one you add this one become 100%. So if the question you see AMU1 actually is something missing in this calculation, means maybe it asks you to find ferrum 57%. What is the percentage isotope of this isotope? If you have this information, this one missing, and you're given this AMU, what is the percentage of this one in the distribution? Okay, so this is how we ask you lah. So yeah, so these are the keywords that help you to solve problems. If you see grams, then usually you solve in the mole and do something else. But if you see AMU, usually you need to work back these distribution things. It is a link to isotope problem lah. Understand? Get it? Okay. All right. Ferrum. Okay. So how many atoms in 55.849 grams of ferrum? So again, you need to recall what is Avogadro number or Na number. 6.02 10 power 23. In this case, is atoms. So you take 55.8 55 gram, you divide the number. Okay. So in your answer, usually in your answer, you need to tell me what actually you understand. You don't straight away give me the value. So when you solve question in energy dynamics, you need to write some equation. You write 1 mole of ferrum equal, or you write Avogadro number, you write this one. You write Avogadro number, Na equal 6.02 10 power 23 atoms. This one usually will cost you 1 mark. You write this one out, you get 1 mark. Then you write 1 mole of ferrum have so many grams, contain this one. So you do calculation. Then how many atoms are there in 1 gram of ferrum? How many atoms in 1 gram of ferrum? This is just a mathematics. Okay. So how you do if you want to calculate how many atoms in 1 gram? So in 1 gram, you just take this one, put over here. This one divided by this one. 1 gram equal this one. So you take this one. Okay. Or it asks you 1 atom, how many grams? So you move this one to here. Okay. So this is just more mathematics. Important for this slide is AMU number. When you use a AMU number, or what kind of situation you need to, or how you solve when you see AMU number. AMU number normally linked with the isotope question. Gram usually linked with the Avogadro numbers. Okay. Right. Important is a unit. Proton is a unit. So usually the answer will be 2 marks. If you only give me the value without unit, we will 50% discount the answer. So if this one, the yellow box here costs you 2 marks, you forget to put in the unit, you only score 1 mark, 1 point for the answer. Okay. Then in the calculation here, in your working here, also important you put in the unit. Okay. So you say, Dr. Ang, can I not put unit? The answer is yes. But in your answer somewhere, you need to tell me what is this? The value you use is what is that? For example, don't suddenly give me 6.02 10 power 23 in somewhere in your answer. You need to tell me, you need to write this one. Na equal to what? Or you need to write 1 mole equal to these atoms or molecules. You need to write this one. Don't in your working suddenly you give me these numbers. Then I will circle and question. There's a question mark there. Okay. Okay. So mass gram of one atoms of ferrum, same again. You just flip the calculation. So based on the answer in part E, what is the mass in gram of 1 AMU? Okay. So actually it's the same. This question actually asks you, do you understand what is the relationship between gram and AMU? They actually is the same. It's only the application is different. The right? It's the same thing, huh? Mass in gram and 1 AMU, they are the same thing, only it's the application of that answer is different. AMU again is more on the isotope distribution, and gram is more in finding at number of atoms, how many grams, and so on. Yeah, 2 different dimensions, two different directions. Okay, so if you understand this one, then you should be fine in your test one. Right. All these are the careless mistakes area. Okay. So this one, if you want to put in gram, so mass in gram of 1 AMU, so you take 9 point something. This one. This is 9 point something is gram of 1 atoms. So 9 point something, you divide by 58 AMU. So it's gram and AMU. So means is 1 AMU equal to this gram. This one asks you 1 AMU equal how many gram? Yeah. Maybe it takes some time to. Second question. This one, you've seen this one in your secondary school exam in chemistry or SPM chemistry to find the Y and X or Y. So you're given a chemical formula, NiX percentage, ALY percentage, where X and Y is simple integer, so it's a full number. Consists of 42% WT means weight percentage of nickel, 57.96. WT is weight percentage. WT is weight that you learn in your physics, W, weight percentage. Or again, this is a material module. Material module, actually, it doesn't separate weight and mass. But I try not to confuse you with the physics or other engineering module. Okay. Consists of so and so percentage of aluminium. What is the simplest formula for this nickel aluminide? So how you do? If you see this kind of question, you simplify the question in the dimension of 1 mole. So you start with 1 mole of nickel and aluminium. Have how many? Yeah. So and then also you need to assume something. In this case, you can assume 1 kilogram, but in this case, I just put 100 grams. You can also put 10 grams if you want, or 1 gram if you want. Okay, so I see this question from 1 mole dimension, then I assume I have so much of amount of that compound. So we are using 100 grams of compounds. So let's say in this compound means if you 100 grams of nickel aluminate, you 100 grams of NiX and Ly. So how many grams you have in nickel? How many grams? Need to calculate, man. No need lah. You see, you already know. How many? You understand the statement here, not? Huh? If you have 100 grams of this one, how many nickel? 42.04 gram. Then 57.96 gram of aluminium. Right or not? Can I? Can I? Can I? Okay. Who don't understand why we get the red color answer? All right. So you have A and B. Let's say that. It tell you, let's say A have 20%, B have 80%. Then it tell you A and B is 100 gram. So how many A? 20 gram. This one 80 gram. Understand not? So if you don't know what is A, you take 100 gram multiply by 20%. So you get 100, or a slower one, 20 over 100 equal 20 gram. Same with 80 grams. So you use this understanding, apply to this question. This question, maybe all these decimal confuse you, but actually it's the same principle. Yeah? Then you refer to periodic table. So for the next class, you print out the periodic table from my slides, or you put somewhere along your tablets when it comes to engineering dynamics, engineering material class. So periodic table, 1 mole of nickel, you have how many grams? Aluminum have how many grams, right? So in periodic table, this one, print this one out if you have time. So you want to find 1 mole of nickel and 1 mole of aluminum have how many grams? So you go to the periodic table, go and find aluminum and nickel. Where is the aluminum? Aluminum is a popular element in this module. Where is aluminum? Row how many? Row aluminum, where is it? Row 6. Huh? Row 2. Row 3 here. So here you see what you see, aluminum. We didn't concern about the tin, but what we want to know is the number below that. This means 1 mole have so many grams. If you see AMU means this is the isotope already. Isotope question. So in this case, we are using gram, means we are finding number of atoms there. Then what else? Nickel. Where's Ni? Where's Ni? Row 4. Yeah. 58.96. or 6.9. Okay, be familiar with this periodic table. Make a good friend with this periodic table. Okay, copy this number into back to the question. So 1 mole of nickel have so many grams. 1 mole of aluminum have so many grams. So, 100 gram have this one, 100 gram have this one. So, can you link this number and this number? We want to know how many mole, right? This so much contained here, 42.04 actually equal to how many mole you want to know. You put all your answer in mole. Okay, so you have 42 grams of nickels equal to how many mole? So you take this number, divide this one, you take this one, right? Divide lah. So for nickel, you take 42, divide 58, get a certain number in unit of mole, MOL, mole. You do the same for aluminium. 1 mole, you have 66. So you take 57 divided by 26. In this module, minimum 3 significant figure or 3 decimal place to be safe. If can, give 4. Minimum 3. Then you get 2 point something mole. Okay, so once you have this one, so your x is 0.7, y is 2.1. However, the question already mentioned x and y is a single integer. You need to get this one as a single integer. It's a mathematics. Okay, so total you have 2.864. It's the same like this one. You know how to calculate percentage now you want to know how many mole in terms of this one. So you take total number of mole and you put into fraction. Mole fraction, you take 0.7 divided by 2.8 means the total mole you have inside the container. How many mole you have? So you get a number 0.25. Can you guess what is aluminium mole fraction? 0.75. You should get 100%, right? So you take 2.1 divided by 2.8, you get 0.75. So what is the full number? How you get full number? You divide lah. This one divide 0.25, this one divide by 0.25. Why? This one? This one? No, this one plus this one equal this one. That one is a ratio, mathematic ratio approach. A bit dangerous if you use that method for material. You solve the question by mole in the mole dimension. Okay, so this one is percentage. If you take this one, this actually 1, and this one actually 3. Okay, so your x and y is 0.25 and 0.75, but we don't want this number, so this one is become 1 and 3. So this one add you will get 1 or 100%, 25% and 75%. Okay, so this is how you work out the x and y for chemical. So again, recap the general idea when you want to solve something like this. You focus your solution in mole dimension. That is the first idea you need to have. I need to solve the question in mole. Okay. Then you assume you have a certain amount of that thing. Okay. So in this case, we assume 100 gram. You can assume 1 kilogram if you want, but kilogram a bit big lah for engineering materials. Any question? Okay, yeah, nothing complex here. So only you need to remember what you should do. Do in mole, then assume you have 100 gram, then you solve the ratio. Okay. Now we start to go into electronic structures. Okay, electronic structures. So this one you read lah. This one you read. I won't test you this one. What is important is speed of light is 3.10 power 8 meter per second. Okay, this one. Okay, electromagnetic wave, there are few unit here. Electromagnetic wave, they in the wavelength, frequency and speed. Right. So you have a second formula. I think the first formula good. So first formula is this one. Second formula is C equal to F lambda. C is 3.0010 power 8 meter per second. This one. Also assume you know already. So two number, one is Avogadro number, one is speed of light. Frequency will be given in the either this one missing or this one missing. Okay, we assume this one you know, either this one missing in the question or this one missing in the question. So you're given frequency. Frequency is in hertz or 1/second. Speed in meter per second. So when you have C equal to F lambda, you actually can know what is the type of radiation that you have. Okay, you will see this chart in the question. Your job is to remember this one. This one you need to remember 3 point something 10 power 8. If you're given frequency, you can find lambda. Right, this one you put to the left is divide. Then there's a number for this one. Once you get this one, you refer to this chart. This lambda is wavelength. So it depends on where is your answer lah. You go to this chart, you draw a line, you go to find the location of the number there lah. Okay. Let's say you get lambda equal to 2.035 10 power 3. Where is this location? 2.03 10 power 3 is somewhere here. Here is 10 power 1. So here is 10 power 1, 10 power 2 is here. Then 10 power 3 is here. 10 power 4 is here. You have 2.3 is somewhere here. Somewhere not here. Somewhere here, you draw a line. You actually very near to visible, or it already enter into infrared radiation. So infrared means application is like heat lamps and all this. It start to create heat already. Okay, so application of this formula C equal to F dot lambda, it depends. If you are given, it depends lah. So for example, the careless mistake here is that you don't know how to read this scale. You read the wrong side of the scale. So for example, I give you another one. Frequency equal to 5.6 10 power 5. Where does this go into? This one in the hertz. So where does this fall into? X-ray, microwave, radio wave. If you have frequency 5.6, 10 power 5. Where's 10 power 5? Yeah. 10 power 6, 10 power 5 is here. So 5 something is here. Here, then a bit to the left. Then you go here, is about radio wave. Is about AM radio there. So when you have radio, so you can communicate in the very low frequency. Okay. Yeah, something like that. So this is how you apply the second equation. Okay. Okay. Then sometimes you'll see very colorful diagram. Same. You ask you based on wavelength, what color you see. If it fall between here, if the frequency or the lambda fall within here, then you need to refer to this chart. Okay, this one actually we expand this one to this diagram. Okay, visible diagram. So if the value is wavelength is about here, 600 nanometer is 600 nanometer. Here, you will see red color. So like those different lights will give you different frequency. Some light they are harmful to your eye. Some light they are very useful in night vision. So it depends on the frequency. Okay. So yeah, then the proton energy. This one is another dimension. We will learn about this one later. It's called photon energy. You solve the question, and then at the end you get one photon energy. You go to this chart again. You will see what color transmitted from that reaction. Okay. Now the careless mistakes here is you are not careful in the unit. This one is tera. Tera is 10 power 12. You are careless in the unit here. So tera, 10 power 12, and so on. So nano 10 power 9. This is 10 power 9, 500, 600. This is terahertz, 500 terahertz, and so on. Okay, so this is another thing. This is another illustration. All right, this extract from here. So if you know the wavelength, then you know where is it, and then the spectrum of color. Whether it's go towards infrared or you go to ultraviolet. This one a bit harmful already. Move toward X-ray that side already. Okay. Okay, a little bit more. Okay, so another number that you need to remember is Planck constant. Planck constant. Planck constant H. H. Usually this one I will give you one. Planck constant. 6 point something, 10 power 34 joule second. F equal to just now, C equal to F lambda. Second one is E equal to F dot H. Same. One constant H is sometimes we give, sometimes we give, but usually if I give this kind of question, I'll give you this one. Right, but it's about 6 point something, 10 power negative 34 frequency and energy. So if these two missing, usually you need to use this formula. So how you get F? You take C equal to F lambda, move the lambda to the left, you get frequency, you get one answer there, substitute here, you get energy. Okay, it depends on how you write it lah. Okay. Okay. These two, or you can remember as E equal to C lambda H. Again, the application of this formula is the spectrum diagram just now. This E is the energy, so it's somewhere here. This one. Okay. Okay. Again, what we learned today, Bose model. Then we learn about AMU. We learn about one more, how many atoms. And then Avogadro number, 6 point something, 10 power 23 atom molecules. Then just now we learn about application of C equal to F lambda. C equal to F lambda. Then we learn about E equal to FH. Right, application of this diagram, these two diagram. So again, frequency, usually C you need to remember, C equal to 3, 10 power 8 meter per second. So this one constant. Frequency you need to find, or you need to find this one. It depends on the question, but either of it will be missing. Okay, so remember the careless mistakes. Remember, don't read the wrong side. Don't read the wrong side, especially this diagram. Especially this diagram. So I did show you two example. 10 power 10 power 3 is where? Is somewhere here and not here. Then frequency 5 point something, 10 power 5 is somewhere here. You will see microwave radiation. So the question actually quite simple. You ask you, once you do your analysis, will ask you what type of radiation from this reaction. You go to this table or this chart, you do your calculation, then at the end you draw a line, then you tell me where's the line landed. If it landed at infrared, then infrared. If it landed at visible, then you need to expand this one into this graph. If it landed here, then you need to look into this one. So of course, if you printed, you'll see black and gray color, but it will tell you some wording here. Don't say, hey, Dr. Ang, I cannot see a colorblind, but you can read, right? Okay, so towards right, it will be red. Towards left, it will become violet, ultraviolet, or violet, right? Okay. 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 Next week we'll go into this calculation of energy already. So Bose models, atomic number, periodic table is what you need to focus today. Okay. No question. We continue this one next week, Monday. Okay. We dismiss here.